Hi, I'm your teacher. So, every day, every week, to start off the class, we'll have a few fun questions of the day, and then try to do them before class. If you get an answer, you can send a private message to Gordon Chen, the host. He's going to be my TA. Please send all messages to Gordon Chen. Okay, so I'll start class now. And please do not send answers to the fun questions to me. Send them to Gordon Chen. Okay, so this class will be AMC Advanced. So this is about your instructor. I'm a freshman at Mission San Jose High School, and I enjoy learning and tutoring STEM. I actively participate in and win various awards in math competitions. So this is going to be about how our time is going to be spent. There will be one class per week for a total of 8 weeks. Each class will last about 1 hour. We will spend a few minutes covering the homework from the previous week, and then about 15 minutes on the lecture. And then after that, we will just be doing exercises. This is the topics that are going to be covered each week. Week 1 is Algebra Part 1, and week 2 is Algebra Part 2, and so on. Week 8 is going to be a review of all of the previous weeks. This is what the today's lecture is going to cover in terms of topics. It's going to cover integers, fractions, decimals, percents, exponents, radicals, and word problems. Okay. The answers to the fun questions were, for number one, the frog and well problem, it was 28 days. And for the chicken rabbit type problem, the answer was 6 chickens. So integers. First, we are going to cover the order of operations. The It is first parentheses, then exponents, then multiplication or division, and then finally addition or subtraction. A mnemonic for remembering that is PEMDAS. Frederick Gauss is one of the greatest mathematicians of all time. According to a well-circulated story, when he was 7 years old, he discovered a quick way to add up all the numbers from 1 through 100. Here's Gauss's clever trick. Let S equal 1 plus 2 plus 3 all the way to plus 99 plus 100. Reverse the order of the numbers. Now, when you pair all of these up, you get that 2s equals 101 times 100. And then when you divide by 2, you get that s equals 5050. Here's your first example problem. Please send if you get an answer for the problem, please send it to Gordon Chen. Please do not send them to me. Okay, so for this problem, let there be R red marbles, G green marbles, and B blue marbles. So from the fact that all but 6 are red marbles, you have that B plus G equals 6, and you can use the other two facts similarly. When you add up those three equations, you get that 2 times R plus B plus G equals 18, which tells you that there are 9 marbles in the jar. Okay, our next topic is fractions. A fraction is the ratio between two numbers. For example, the ratio between 3 and 4 can be written as a fraction 3 over 4. More generally, the ratio between a and b, where a and b are integers, can be written as a fraction a over b. The integer at the top is called the numerator, while the integer at the bottom is called the denominator. The denominator can never be equal to 0, otherwise you are dividing by 0. Is called a proper fraction. A over b is a proper fraction when a is less than b. For example, 2 over thirds is a proper fraction. A over b is an improper fraction when a is greater than b. For example, 5 thirds is an improper fraction. A mixed number is a number that is written as the sum of an integer and a fraction, as in a and b over c. For example, 3 and 2 over fifths can be written as the mixed number 3 and 2 over fifths. The reciprocal of a number or a fraction is the result when we divide 1 by the number or fraction. It is also called the multiplicative inverse because when you multiply the two numbers, when you multiply the number and its reciprocal, you get 1. The reciprocal of a over b is just b over a. For example, the reciprocal of 2 thirds is 3 halves. You're basically just flipping the numerator and the denominator of the number. Now, here is your next example. Once again, please send answers to Gordon chat, not me. Okay, I'll start explaining this problem now. So, the denominators are 4 and 5. Because you can't have a fraction of a person, there must be at least 20 people in the room. Okay, there must be at least 20 people in the room. To minimize this, we'll just assume that there are 20 people. So, of those 20 people, 8 are wearing gloves and 15 are wearing hats. So this accounts for 23 people, but there are only 20 people, so the minimum number of people in the room wearing both is 3. Our next section is going to be decimals. A decimal is simply just another way of writing a fraction. We just use decimal representation and divide the numerator of a fraction by its denominator via long division. For example, the fraction 2/5 can be written as the decimal 0.4. It is also possible to write them as terminating as unterminating decimals, but we won't use those. Here's your next problem. Okay. So from these two pieces of information, okay, from these two pieces of information, we have that he scored a total of 111 points. His season average is 18.5 points per game. So this means that the number of games he played is simply 111 divided by 18.5, which is simply 6. What? So percents. Percents are a way to express a number out of 100. For example, the number 60% represents 60 out of 100, or 60 over 100, or 6/10, or 3/5, or 0.6. To convert from a decimal to a percent, simply multiply the decimal by 100. For example, the number 0.25 represents the percent 25%. Here's your next example. One more minute for this problem. Okay, I'll start explaining the solution now. So 7% detergents. That means that 93% of it is not detergent. This is also equivalent to 186 milliliters of non-detergent.
You are muted.
Yeah, I know, sorry. Had a technical difficulty. Okay, 186 milliliters. So in order for now, there will be 86% non-detergent when there's 14% detergent. So 86% of 200 plus X will be the amount of 100% detergent added must equal 186. And then solving this equation says that X equals 16.3 milliliters. Our next topic is exponents. Exponentiation is a way to concisely express iterated or simply repeated multiplication. Just as multiplication is the same as repeatedly adding a number, exponentiation is simply repeatedly multiplying the same number. If we have two numbers a and b, where b is a positive integer, we define a to the power of b, or a with an exponent of b, as this symbol. This is equivalent to multiplying a by itself b times. On the other hand, a to the negative b is equal to the reciprocal of multiplying a by itself b times. This is the next example. Okay, so one key thing to note in this problem is that it's the same number over and over for a total of 4 times. So 2 to the 2 to the power of 2 equals 16 equals 2 squared squared. This is another important observation. 2 2 squared squared. Okay. So this leaves us with only 3 possibilities. 2 to the power of 2 squared squared. This is one possibility, and it just equates to 2 to the 16th. Another possibility is 2 squared to the power of 2 squared. This equals 4 to the 4th equals 256. A final possibility is 2 squared squared to the power of 2. This also equals 256. As a result, there's only one other possible value. Our next topic is going to be radicals. An nth root of a number a is a number b such that b to the power of n equals a. We denote that nth root of a by this notation. The second root of a is also called the square root of a and is given a special notation, this. The third root of a is known as the cube root of a and is denoted like this. Here's your next example. if you want a hint, l- let substitute variables for each of the two expressions for each of the two radicals and see what you can do with that. Okay. So continuing on with this hint. Next note that AB equals 3. It equals 9 squared minus 6 root 2 squared, which is great. Okay, A and B. So AB equals square root of 81 minus 36 times 2 equals 3. In addition, A squared plus B squared equals 18. A plus B squared equals A squared plus B squared plus 2AB. Okay, so this tells us that a plus b equals square roots of 18 plus 2 times 3 equals 2 root 6. An interesting fact is that these two are simply just root 6 minus root 3 and root 6 plus root 3. Word problems. So, word problems can cover almost any category, and they're usually not that hard. The main tricky thing about word problems is that sometimes there might be some stuff hidden in the problem that's meant to trick people. Okay, so the first sentence just means that these are Jack's and Bill's ages, where A and B are digits. These numbers equal 10A plus B and 10B plus A. Oh no. Okay, so these equal 10a plus b and 10b plus a. So now you have that 10a plus b plus 5 equals 20b plus 2a plus 10 from the second sentence. This just get the equation 8a equals 19b plus 5. The only possible solution to this is among the one digit numbers is a equals 3 and b equals 1. This means, oh, come on. This just gives the only solutions to these equations are a equals 3 and b equals 1. So the difference between their ages is 31 minus 13, which is simply just 18. Did that go through? Okay. Alright. The difference between their ages is 31 minus 13, which is simply just 18. So now we're gonna move on to the exercises. Here's the first problem. Please send answers to Gordon Chan. Okay, let one soccer ball costs $B and one soccer shirt costs $S. So B plus and the soccer shirt costs $S. Is this writing anything? No, it's not. Okay, I'll just finish explaining this one by speaking. So one soccer ball costs $B and one shirt costs $S. So you get the equations B plus S equals 100 and 2B plus 3S equals 262. Okay, I can write again. $S So 3b plus 3s equals 300. And when you subtract the start equation from equation 1, you simply get that b equals $38. You can now work on the second problem. Okay, first off, a little hint is that you can easily count how much cream Joe has. Joanne needs to find how much cream Joanne has, you need to use a fraction. Okay, so After Joanne adds her cream to their coffee, she has 2 ounces of cream and 14 ounces of coffee. Really illegible. 14 ounces of coffee. Oh my god. 14 ounces of liquid. So the amount of cream in Joanne's coffee after she drinks 2 ounces out of her 14 ounces is just 6/7 of 2. When you compare these ratios, you get 2 divided by 6/7 times 2, which gives you an answer of 7/6. This will be the last exercise for today. This problem.
What's a rebate?
A rebate. Okay, so store A is basically you get you get it at they will pay you $90 and you get 85% off. 85 and you pay 85% for it.
Okay.
Okay, for this problem, you don't actually need any equations, despite what you might think. Heather saved $15 by buying the computer at store A instead of store B. That means that if store A only offered a 75% rebate, a $75 rebate, then the price would have been equal to that of store B. And since the difference between store A's and store B's prices is 10% of the sticker price, that just means that the sticker price is simply $750. Okay, I'll go back and explain the fun question that I did not explain earlier. So the answer to this problem was 28, if you still remember. So on average, every day it goes 1 meter up. However, on the 27th night, it is at 27 meters. And at the morning of the 28th day, it jumps up to 30 and it escapes. So the answer is not actually 30, but is rather 28. For the chicken rabbit problem, if all the heads were chickens, there would be 28 feet. However, there are 44 feet, which means that there are an extra 16 feet brought in by the rabbits. Each rabbit has 2 more feet than a chicken, so this means that there are 8 rabbits. There are 14 total animals, so there are a total of 6 chickens. If you have questions about anything else, you can ask right now. Right. And if you do have any questions, you can put them in the public chat. Okay, so I guess this is it for today because there seems to be no more questions. Uh, before you leave, I will be assigning homework today, and all of you can thank my brother Gordon Chan for helping me be a TA. He's a 7th grader in Hopkins right now. I will be leaving homework, and there will be I will be leaving homework in Google Classroom, and you can also find a recorded Zoom video in Google Classroom as well. Thank you for attending this class. You can now leave.
Bye.